Hello students. So we'll continue with the problems based on Pythagoras theorem. So we are done till question number 8. So let's start with question number 9. So there is a ladder 10-meter long, reaches a window 8 meter above the ground. Find the distance of the foot of the ladder from the base of the wall. Okay. So let's solve this. So there is a ladder. Let's say okay. The one which I am drawing now is the ladder. Okay. This point is the window. Okay, let me take it as point A, and the height of the window from the ground is 8 meters. Okay, and the ladder is 10-meter long. Okay, and we have to find, this is the foot of the wall and this is the foot of the ladder. So let's join that. We have to find this distance, foot of the ladder and foot of the wall. We know that wall will be perpendicular to the ground. So let me take this point as B. Let me take this as C. What we have to do is we have to find the value of BC here. That's it. Okay. This is question number 9. So it's a right angle triangle. So very clearly we're going to use Pythagoras theorem. In triangle ABC, angle B is 90 degree. Therefore let's use Pythagoras theorem. If you use Pythagoras theorem, what do we get? We get AC square is equal to AB square plus BC square. We know the value of AC, that is 10. AB is 8. We have to find the value of BC. So AC square is 100. 8 square is 64. 10 square is 100. 8 square is 64. We have to find BC square. Now 100 as it is, 64 to the LHS, it will become minus 64. That will be equal to BC square. So 100 minus 64 is 36 is equal to BC square, which implies BC is square root of 36. Square root of 36 is how much? 6, which implies BC is equal to 6 centimeters. Sorry, 6 meters. 6 meters. Let me write it properly. 6 meters. That is the distance between the wall and the foot of the ladder. Okay. Similarly, let's get into the next question. These are very simple questions, but important for the exam. So the 10th question, a guy wire, it's a kind of wire, that's it, okay. A guy wire attached to a vertical pole of 18 meter is 24 meter long. So that is, the height of the pole is 18 meter and the length of the wire is 24 meter. And as a stake attached to the other end, how far from the base of the pole should the stake be driven so that the wire will be a taut? Okay. Okay. So here, let me share the screen. This is question number 10. Okay. So what we have got is, we have got a vertical pole of height 18 meter. Let's draw that. Let's say this is the vertical pole of length 18 meter. Let me name it as AB. Okay. Okay. And we have attached a rope to it. And there is a stake. Okay. Stake is kind of a stick where we have tightened the rope. The rope should be stiff enough. And let's say this is the point C where we have tied the rope. Okay. We have to find the value of BC here. Okay. Obviously, the pole will be perpendicular to the ground. The length of the rope is given as 24 meters. We have to find the value of BC. Again, let's use Pythagoras theorem. In triangle ABC, angle B is 90 degrees. If you observe, I always mention the right angle, then proceed with the theorem. Using Pythagoras theorem, we can write it as AC square is equal to AB square plus BC square. So AC is 24, AB is 18. We have to find the value of BC. 24 square is 576, 18 square is 324 plus BC square. So we don't want 324. So let's send it the other side. That is equal to BC square. So 576 minus 324. We get it as 2, 7 minus 2, 5, 5 minus 3, 2. So it will become 252. 252 equals BC square, which implies BC is square root of 252. Let's prime factorize 252. That is, we are trying to get it in the simplest form. Okay. So 2 1s are, 2 2s are 4, 1 carry, 2 6 are. So 2 6 are, 2 3s are, 3 2s are, 3 1s are, 3 7s are, 7 1s are 7. Yeah. So therefore, this is a pair. This is a pair. So from each pair, we'll take 1 1 number. So 2 into 3. The number without pair stays inside the root. So it will become 6 root 7. That will be the length of the BC. Okay. Let's continue with the next question. The 11th question, an aeroplane leaves an airport and flies due north at a speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 km per hour. How far will the two planes be after 1.5 hours? Okay. So let's solve this. Let's say point A is our airport. Okay. So let's take one color. So there is a plane which is flying north. Let's say this is the plane that is flying north. Okay. Now let's say this point is B. That is after 1.5 hours, the aeroplane which was traveling in the north direction is at B. Okay. Now let's take another aeroplane which is flying west. Let's take it like this itself, doesn't matter. So let's say after 1.5 hours, the flight is at C, the point C. What we have to do is actually we have to find the distance between B and C, the distance between the planes. Okay. That is the BC value. This is the value that we have to find. Okay. Now, speed of the aeroplane in north direction is 1000 km per hour, which implies in 1 hour, if it flies 1000 km, in 1.5 hours, it would have flown a distance of 1500, isn't it? So this distance will be 1500. The speed of aeroplane in west direction is 1200 km per hour. So 1 hour 1200 km. 1.5 hour, it will become 1800, isn't it? So this is 1800. So here again, the angle between the north and the west will be 90 degrees. So using Pythagoras theorem, in triangle ABC, angle A, let me draw it properly. Angle A is 90 degrees. So using Pythagoras theorem, here we get BC square is equal to AB square plus AC square. BC is the hypotenuse. BC square is equal to AB is 1500 whole square plus 1800 the whole square. So 1500 the whole square. 15 square is 225. There are two zeros. If you square it, it will become 4 zeros. Similarly, 18 square is 324. Two zeros. If you square it, it will become 4 zeros. Therefore, this will become 549 followed by 4 zeros. That is the value of BC. Okay. Now, BC will become square root of 549 zeros. Now, if you take square root, how many zeros? Like if you got 4 zeros, it will reduce to half of it. There is 2 zeros. Therefore, you can write 100 outside, or let me write it like this. This can be written as 549 into 10,000, isn't it? There are 4 zeros, so I can write like this. So again, if I split it, it will become square root of 549 into square root of 10,000. Square root of 10,000 is how much? 100. So it will become root of 549 into 100, or I can write it as 100 root 549. This 549 can be further simplified. This goes by 3 tables. 3 ones are 3, 2 carry, so 3 8s are 24, 3 3s are 3 6 are 3 1s are 61 itself is a prime number. So this is a pair. Out of this pair, we'll take one number outside. One without pair stays inside the root. So 100 into 3, 61 doesn't have pair, so it stays outside. So it will become 3 into 100 is 300 root 61 kilometers. That is the distance between two planes after 1.5 hours. Okay. So let's get into the next question. The next question. Two poles of height 6 meter and 11 meter stand on a plain ground. Okay. If the distance between the feet of the poles is 12 meter, find the distance between their tops. Okay. So what we have got is, we have got two poles. One is of height 6 meter. Another one is of height 11 meter. So let me draw two poles. Let's say this is the first pole. Okay. Let's take another pole like this. Okay. So the first pole, let me name it as A, B, which is of height 6 meter. The other pole, let me take it as CD, which is of height 11 meter. Okay. The distance between their bottom, that is the feet, is 12 meter. We have to find the distance between their tops. Let me take black color to indicate the tops. That is the value of AC that we have to find, question mark. Okay. So very clearly the angle at B will be 90 and angle at D will be 90. Okay. Now let's make a small construction because we are going to solve it using Pythagoras theorem. Therefore, we need a right angle triangle. Let me make a construction here. Okay. So the construction is draw AM perpendicular to CD. So this is the perpendicular. Okay. Construction was draw AM perpendicular to CD. Okay. So that is here the angle is 90 degrees. Now since all the angles of quadrilateral, ABMD are 90 degrees, it implies ABMD is a rectangle. It doesn't become a square because all the sides are not equal. All the angles are 90 degree, therefore it becomes a rectangle, which implies AB will be equal to MD and BD will be equal to AM. So that is AM value will also become 12 meter, and here it becomes 6 meter. Okay, now therefore you can easily find CM, which implies CM value will be the total value CD minus MD. So CD is 11, MD is 6, so it gives us 5. So CM value will be 5 meters. Okay, now easily we can use Pythagoras theorem. This is 5 meter now. Now easily let's use Pythagoras theorem and let's find it. Okay, let me use it here itself. In triangle AMC, angle MS 90 degrees. Therefore, using Pythagoras theorem, we get AC square is equal to AM square plus CM square. AM is 12, CM is 5. So 12 square is 144, 5 square is 25. So we get 169. AC square is equal to 169, which implies AC is square root of 169, which implies AC is 13 meters. That is, the distance between their tops is 13 meters. Let's continue the next question, students. The next question, D and E are points on the sides CA and CB of a triangle ABC right angle at C. We have to prove that AE square is equal to BD square, which is equal to AB square plus D square. Okay, let's do that. So we have to prove AE square plus BD square. Okay, let me take a new page. We have got a triangle. Okay, this is the right angle triangle. It is right angle at C. So this is A, and this will be B, and this will be C. So it is right angle at C. Okay, and D is a point on CA, and E is a point on CB. So let me take D somewhere here. So this is our D, and let me take E somewhere here. This is our E. Okay, and what we have to prove is, we have to prove that, let me look into the question. AE square plus BD square is equal to AB square plus DE square. So AE square plus BD square, we have to prove that AE square plus BD square is equal to AB square plus DE square. Okay, this is what we have to prove. Since we want AE square, let's join A and E. Similarly, whichever is required, we need AE square. Let me join A and E. And we also need BD square. So let's join B and D. We also require DE square. So let me join D and E. Let me join D and E like this. So this will be the final figure. So we'll consider the LHS, same pattern. We'll find AE square first, then BD square, then let's add it. Okay. So proof. So first let's find AE square. For that, I'm going to take triangle AEC, because it is also a right angle triangle and it has got AE in it. Okay. Angle C. Using Pythagoras theorem, we get AE square is equal to AC square plus CE square. Equation 1. Now we want BD square. For that, in triangle BCD, that's what we have to take. So angle C is 90, and using Pythagoras theorem. Using Pythagoras theorem, we get here BD square is equal to CD square plus C square. That will be equation 2. Let's add equation 1 and 2. Add 1 and 2. How do we add LHS with LHS? So that is AE square plus BD square. That is equal to RHS plus RHS. The first RHS is AC square plus C square. With that, let's add the other RHS, CD square plus C square. Okay. Now, AE square plus BD square. Let's rearrange this, the RHS. Let me write AC square plus one second. Here, I guess in the first equation, okay, this second equation, we have made a small mistake. This should be CB square, not CE. Okay. So this becomes CB square. Okay. So AC square plus CB square, CE square plus CD square. Okay. If you observe the figure, CS, that is AC square, that is this one, this full length, and this full length, square of these two will be equal to AB, isn't it? So AC square plus CB square, so LHS as it is AE square plus BD square. The LHS AC square plus CB square will give us AB square, and in the same pattern CE square plus CD square. If you observe, CE square is this, CD square is this. It's a right angle triangle, so if you use Pythagoras theorem, you will get this, isn't it? So we get CD square here. That is E square plus D, C square plus CD square is D square. Okay. Or if you're getting confused here, what you can do is, after adding equation 1 and 2, we have got this, isn't it? After adding equation 1 and 2, we have got this. Now next, what you can do is, you can find AB square and D square, add it. Okay. Find AB square and D square, you will get the same thing. Whatever RHS you have got here, you will get the same thing. Therefore, you can tell those are equal. Okay. You can also do it like that, which will be less confusing. It will be easy also. You can do it like that. Find LHS separately, RHS separately, then on comparing, you can tell both are equal. Okay, students, let's continue the remaining problems in the next video. Thank you.